Hey, welcome back to your favorite pre-calc class. We're doing section 1.3 today, lines. We're going to talk about slope and slope form, all the forms of the equations of a line, and we'll get into parallel and perpendicular lines amongst many things. So today, kind of again, an overview, a review of your line understanding. So here's the slope equation. It's y2 minus y1 over x2 minus x1. Slope is defined as your rise over run. Now, slope is rise over run, which is the vertical change over the horizontal change. Okay, so you notice rise, how much are you rising for how much are you running, or you can look at it in the red there as well. So let's do an example. Let's say you're finding the slope of a line. This is just your steepness of a line. So you go y2 minus y1 over x2 minus x1. Here's your x1, y1. Here's your x2 and your y2 right there. And we just plug it in. Our y2 is negative 3 minus our y1 is 2 over 5 minus 1, x1. So we've got negative 5 over 4. So there's our slope, negative 5/4. That's how you find this slope of a line. That just means that for every 5 units down it'll go right 4, horizontally 4 to the right. Now notice that what we just did had a negative slope, right? So similar to the one in orange here, you see if you have a negative slope, you're going to have a line that's going down and to the right, whereas a positive slope is going to go up and to the right. A zero slope will be horizontal, and a vertical slope would be undefined, and you could find those if you're doing those algebraically with points. Let's draw a graph now. If we have the point 3, 2, the point 3, 2, and we have a slope of, remember, slope is rise over run. We have a slope of negative 4 over 5. So rise means do you go up or down? If it's positive, you go up. If it's negative, you go down. Run is your horizontal change. That'll mean the run part tells you if you go right or left. Positive if it's right, negative if it's left. So notice the top numerator value is negative, so we're going to go down 4 since it's negative, and the 5 on the bottom, since it's positive, tells us to go right 5 from the point that's given, 3, 2. So we're going to go down 4, 1, 2, 3, 4, and right 5. 1, 2, 3, 4, 5, and we're going to put the point right there, and you can draw it right there. So from the point 3, 2, you go down 4, right 5. Now, note, negative 4/5 is the same as 4 over negative 5. All right, so you could go from the point up 4, since positive, and left 5. And you'd still be on the line. Up 4 and left 5. 1, 2, 3, 4, 5. And you'd still notice it's still on that line if you were to draw that. Okay. Now, what if you're graphing an equation where you have just x equals a constant, x equals 3 in this case? What I like to do is if you can't remember, is this the vertical one or is this the horizontal one? Well, just plug points in. This is saying x is always 3. It doesn't matter what y is. There's no y involved in the given equation. So whatever y is, just throw in some y's. X is always 3. So you got the point 3, negative 2, you got 3, negative 1, you got 3, 0, you got 3, negative 2, 3, negative, oh my gosh, sorry about that, 3, negative 2, I got 3, negative 1, oh, come on, draw for me, draw, erase that, I gotta draw, 3, negative 1, there we come on, and we got 3, comma 0, we got 3 comma 1, we got 3 comma 2. Boy, I'm struggling with this pen right now. But anyways, you start plotting those points and you can see that vertical line, x equals 3. Thanks for your patience on that. So anytime you have a vertical line, x equals a constant, like x equals -2, you're going to see a vertical line. X is always -2, and you could plot those points if you care to. Now here's your point slope form of the equation of a line. So you got y minus y1 equals mx minus x1. M, of course, is your slope again. x1 and y1 is the point that is on the line, one of the points that's on that line. So let's do an example. Let's find an equation of a line that contains the points 1, 2. So here's our x1 and our y1, and it has a slope of 4. So our slope is 4. So the first thing we're going to do is we say, oh, I have a point and a slope. I'm going to use point slope form. I'm going to write my point slope form equations. So I'm going to go y minus, I plug in my y1, which is 2 here. I plug in my 4 for my slope, and then I plug in my x1, which is 1. Okay. Now this is an equation of the line. You could stop right there if it says write an equation in point slope form, or if you're going to if you're going to continue on, you can also put it in the more familiar form, slope intercept form, by solving for y after you distribute. So y equals 4x minus 2. Okay. So either of those, just look at the instructions on those. You notice here's your point. Had a point of 1, 2, and the slope was 4, so it went up 4, right 1 on that. Okay. Alright, let's find the equation of the horizontal line containing the point 3, 2. So now you got the point 3, 2. This thing is supposed to be horizontal. So we've got this horizontal line containing that point 3, 2 right there. My gosh, I can't get this thing to draw that. There we go, 3 comma 2. Find the equation of that. Well, the slope of a horizontal line, the slope of a horizontal line is 0, if you might remember. So we got y minus y1 equals m. We're going to use the slope and the point that we're given is one way to do this. So y minus our y1 here is 2. Our slope is 0 for a horizontal line. Plug in x1, which is 3. 0 times anything, of course, is 0. So you got y minus 2 is 0. You add 2 to both sides, you end up with y is 2. So the equation of a horizontal line is always y equals the constant, whatever the y is, whatever the constant y is throughout on that line, on that horizontal line. So y equals 2 in that case we just did. Let's find the equation of a line now given 2 points. Well, to write an equation of a line with the point slope form, we had to have a point, which we do here. In fact, we have 2 points, and we had to have a slope. So since we're given 2 points, the first step is we got to find the slope first. And then we can use our point slope formula after that. So we got y2, which is 5, minus our y1, which is 3, over -4 minus 2. So we got 2 over -6, or -1/3 once you reduce that. So here's our slope, -1/3. And now we say, oh good, we got a point and a slope. So now we can plug in our x1 and y1, and we'll have, notice I plugged in my x1 and y1 and my m. There is an equation for in point slope form. You could also distribute that and solve for y if you wanted to as well. So we'll go ahead and do that here. So we got y minus 3 is -1/3 x, -1/3 times +2 gives us the 2/3 there. We add 3. Make sure you get a common denominator. So when I add 3 to this side, I'm going to make that 9/3. So we got -1/3 x plus our 11/3. So there's either one of those depending on how the instructions ask you what form to put that in. Alright, now we're going to look at the classic slope-intercept form. It's called the slope-intercept form because you notice you've got the slope here. Let me grab my slope there, and you've got your B stands for the y-intercept. So that's where you cross the y-axis. Okay, so let's find the slope and y-intercept of this equation. Notice that it is not in the form y equals mx plus b. So what we got to do is we got to put it in that form by solving for y. So here's the equation, 3x plus 6y equals 12. We're going to solve for y. So we get 6y equals negative 3x plus 12. Divide both sides by 6, which means each term over there has got to be divided by 6, and we got negative 1/2 x plus 2. So our y-intercept is 2, and our slope is negative 1/2. So if we're graphing this, we would graph the y-intercept of 2. That's where it crosses the y-axis. So it crosses right there at 2. If I can get it to draw there. 2. And then it goes down 1 for the slope and right 2 for the run. Down 1, right 2, and I put a point, and then we draw that thing. Down 1, right 2, and put a point if you want to put a couple points on there. Okay, here's a better. Well, I guess I thought I'd. Alright, so that brings us to the general form. Ax plus by equals c. The general form, if you're given a general form, what you want to do, typically the best way to graph it in general, if you're going to leave it in general form, is to graph by finding its intercept. So if you remember, when we found the x-intercepts, we let y be 0. When we found the y-intercepts, we let x be 0. Okay, so let's go ahead and find the x-intercepts first by letting y be 0. So we have 2x equals 8. 4 times 0, of course, is 0. So we have x equals 4. So our x-intercept is 4, comma 0. There it is right there. Okay. Now let's find the y-intercept by letting x be 0 this time. So 2x plus 4y equals 8. We're going to let our x be 0 this time, and you notice we got 4y equals 8. Divide by 4 both sides, and we get y equals 2. So y equals 2, that means we have the point 0, comma 2 on the graph. And now we got our 2 points for our line. We just need 2 points to graph this. Graph any line. Okay, so if you're given general form, use the intercepts. Now, let's talk about some parallel lines. If you have parallel lines, that means their slopes must be equal. For instance, if this slope is negative 2/3, this slope must be negative 2/3 as well. So they have the exact same slope. Okay, we're going to use that information when we find an equation for the line. In this case, an equation of the line that goes through the point 2, negative 3. So we're trying to find this equation of the line that goes through this point here, 2, negative 3. And it's parallel to the line 2x plus y equals 6. 2x plus y equals 6. And if we were, I'm not going to write out how you graph that again, but that 2x plus y equals 6 looks approximately like that. So we're trying to find the equation of the line that goes through that 2, negative 3, and it's parallel. So we're trying to find the equation of that orange line there. Okay. Well, we already know the orange line goes through 2, negative 3. The only other thing we need is the slope of that orange line. And since they're parallel, what we're going to do is we're going to take the slope from the blue line and use it for our orange line because we know it has the exact same slope. So let's go to the right hand side. This is step 1. Find the equation, find the slope of the given line. So I'm going to put it in slope-intercept form. Here's my slope-intercept form. Y equals mx plus b. So I know my slope is -2 on that blue line. So now I know, since they're parallel, that the slope is also -2 for my orange line. And now I have a point and I have a slope. So I use point slope form to finish this. I plug in my x1 and my y1 as well as my slope. And I just work this down. Subtract 3 on both sides. Okay, so y equals -2x plus 1 ends up being the equation for this orange line right here, -2x plus 1. And it is perfectly parallel to 2x plus y equals 6. Okay, so they both have a slope of -2. Now, let's talk about perpendicular lines now. If you have two perpendicular lines, they create a 90-degree angle, and the product of their slopes is -1. So if I go back to this picture for a minute, let's say that this slope right here, let's say it's 2/3. Well, since the product of these two slopes would be -1, that means that this slope of its perpendicular line would be the opposite reciprocal. So I flip that 2/3 over and I change the sign. Okay, so if the slope is 2/3, the perpendicular line slope would be -3/2. You flip it over, change the sign. Okay, so let's do an example. Let's do that same example. We've got an equation of the line. It goes through 2, -3 again. All right, here's the point. It goes through 2, 2, -3. It's got to be this time, and here's our 2x plus y equals 6. So this time we want the equation of the line in blue. What's the equation of this line in blue? And it's got to be perpendicular to the orange line in this case, right? So we still do the same first step, which is find the slope of the given line. So here's our 2x plus y equals 6. I put that in slope-intercept form. So I know the slope, I should do this in orange. I know the slope of that orange line is -2. Okay, so this slope is -2. Well, since this time they have to be opposite reciprocals, since this time they have to be perpendicular, I'm trying to find the equation of this perpendicular line that goes through 2, -3. And I know that they're perpendicular, so I know that the slope would be the opposite reciprocal. So if you take the -2, which is -2 over 1, you flip it over and change its sign, that means the slope that I need is 1/2. So the slope that I need is 1/2. Let me erase all this. I have a little room here. And now, I say I know it's going through the point 2, -3. I have a slope that is 1/2. Write your point slope form, and you'll have the equation of the blue line. Subtract 3 on both sides. So that's the equation of that blue line there. Alright, thanks for watching. We'll see you guys in class.